Hi guys, it's back on to scientific skills. This time we are talking about measuring with this metric ruler. Pretty critical about understanding how exact you can make a measurement, um, and specifically with the ruler. We'll do some practice and we'll get going. So we have this notebook paper, or sorry, not notebook, card stock notebook index card, just a standard one. And we're going to take some measurements. So we have this a ruler in centimeters. Sorry about that. And you can see between 12 and 13. So we know it's going to be 12 something. And you can see that there are actually 10 spaces in between. Okay, so we know it's going to be like 12.1, 12.2, 12.3, 12.4, 12.5, 12.6, and it hasn't reached 12.7 yet. So we know it's going to be 12.6 something. That something is always going to be a little guesstimate. Okay, so you can't say 12.6 because it's going to be a little more than 12.6, and you can't say 12.7 because it's a little less than 12.7. So if you get really close, I got 12.66. Now, if you said 12.67 or 12.65, that's all well and good because that last number is just a guesstimate. Okay, you always want to have a little bit of an estimate at the end. We know it's 12.6. We just didn't know that exact last number. We can't get an exact number, so it's just a little guesstimate. All right, if we go the other way, the height or width, we have it between 7 and 8. So again, you can see it goes past the half. So we know this is 0.6 and this is 0.7. So you can see it's a little closer to 0.6 than 7. So I said 7.63. Okay. Again, if you had said 6.4 or 6.2, again, those are fine answers because that last number is just a little bit of a guess. And that's the idea of measurements, whether it's a graduate cylinder or a beaker or a ruler, it's always that little bit of guess at the end. So if you know it exactly 7.6, you have to add one more number. And rulers are always going to be the same. It's always going to be 2 decimal places. All right, so some vocabulary. We have known, unknown, estimate, and calibration. So a known is to recognize certainty. So you know exactly that is known, which makes sense, certainty. A unknown is unidentified. So it's not known. Known and not known basically is opposites. An estimate is to judge or approximate a value. And calibration is the smallest space on an instrument. So what does that each space represent? What value? So here we have a picture. So you can classify what are some knowns in this picture. Well, we know she's a girl. We know could be Caucasian. Estimates. We can estimate her age, maybe 6, 7, 8. Mood, kind of pensive. Maybe a little bit of thought process. We know we can estimate the plants. They look like wheat, but we're not exactly sure. Unknowns. We don't know her name. Country. It could be pretty much any country that grows wheat or some type of product, grass. And we don't know the date. It's in black and white, but doesn't mean anything. Now we have all these filters. We can make any picture black and white. All right. The happiest place on earth. We are knowns. We know that the gender is female and male. We don't know Mickey and Mouse, but we assume male and female. The race, the Hispanic. Character names, Mickey and Minnie. Food, breakfast time, so it's breakfast food. Ages, again, we can estimate. Mood, they seem happy, but you don't know exactly if they're joyful or happy or someone said a joke, anything like that. Location, we could estimate that it could be Florida or California, places where there could be Disney. It could be even on a cruise ship. Time of day, we can estimate that it's going to be in the morning because they're eating breakfast, but that is assuming that breakfast is you're eating breakfast for breakfast instead of like some people like breakfast for dinner. Unknowns: name, country, date. Okay. Restaurant, we don't know. It could be a hotel. All right. So this is the kind of same idea with estimating unknowns and knowns with measuring ruler. Okay, so we have this ruler, this length of the pencil. We know that the pencil has to be 9 centimeters. Okay, we can estimate that it's about halfway, or 0.4, so it's halfway between 9 and 10, so we're going to say 0.5. And unknown's not really applicable here because it's just a pencil. We're taking the measurement, that's 9.5 centimeters long. How to calibrate a ruler. So here's simple steps. So what are these steps? Now, 1, you find 2 numbered lines on the ruler and subtract their values. So it doesn't matter what numbers you have, you just use those numbers and subtract them. I always like to do consecutive, 1, 2, 2, 3, 3, 4, so forth, because that means there's less spaces to count. Okay, so let's do 1 and 2. Difference is 1 centimeter. All right, step 2, count the number of spaces that separate them. So number of spaces, not the lines, because there's 9 lines, but there's 10 spaces. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 spaces. Don't count the lines. Okay, 10 spaces. And number 3, calibrate the simply divide 1 by 2. So we take 1, divide by 10, and we get 0.1 centimeter per space. So each space represents 0.1 centimeters, or 1 millimeter. So what does that mean? Again, you can help determine the measurement by looking at how much each space is worth. When measuring, always read an instrument out to the last digit you record is an estimate. So this goes back to that unknown. So you don't really know. If you know all the knowns, and then the last one has to be an unknown or an estimate. Okay, let's try another practice. We have a big ruler with not a lot of space, or not a lot of increments. Big, huge space. Okay, let's calibrate. There's only 2 numbers there, 0 and 10. So the difference is 10. Let me get rid of my thing. There. 10 centimeters, and there's 1 space per space. So we can guesstimate to be 9. Now we don't know it's exactly 9 or 9 something, but we don't know it's going to be, there's nothing number we can't add to that. So it has to be an unknown number of 9. So is that an estimate or a known? If you said estimate, you are correct. And then we need units. Always need a unit. And we're dealing with centimeters here because of the ruler says cm. All right, let's calibrate. Okay, what's the difference between two lines? It's 1, and there's 1 space. So it's 1 centimeter per space. Now we know it's 9. Okay, it's past the 9, but we haven't reached 10 yet. So we know it's 9 point something, 9.4, because it doesn't look like halfway. So I'm going to say 4. Unit, centimeters. Now, is a 4 an estimate or a known? And if you said estimate, you are correct, because we don't know exactly 4. 9 would be a known. Okay, so you always need that last number to be an estimate. It could be the first number, like the previous example, but this time it's the last. It's always the last. All right, we're getting more and more precise in our calibration. So there are now 2 spaces between the number 1 and 0. So that would be 1/2 or 0.5 centimeters per space. So each space represents 0.5. So 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, and so forth. Okay. So what would our answer be? It doesn't look like it got to 5 yet. So we know it's going to be 9.4. Now, we don't know if that's a 4. So again, our unit centimeters, that 4 is still an estimate. Even though our calibration was smaller, our estimate still is the 4. Okay. And again, the 9 is a known. All right, this is our standard ruler. This is the one that you will work with in the lab. And that means the calibration is always going to be the same. Now, if we did 1, again, between 0 and 1, there are 10 spaces. So each space represents as 0.1 centimeters per space. Okay, so we go looking at our pencil, we can see it's just a little bit past 4. So we can say basically 9.42, 9.41. Okay, so which one is our unknown? And that's going to be our 2 again. I'm sorry, estimate, unknown, estimate. And then the other numbers, the 9, the 4, are both going to be known. We know it is past the 0.4. We know it's past 9. We just don't know exactly that it's going to be the 2. And the other unknown is number 4. All right, so here is summary. So again, you can see it went from 9, again 9.3. Okay, you can say 9.3 here as well because there's no new increments that tells you it's 3 something. You can't really say it's 3.2 or 3.3 because there's no new increments. And then here is 3.0 right on the dot. So it's important that you put that 0 because that 3 is known. So you need an unknown and you put a 0 there. So even though it's on the line, you still need that 0 at the end. All right, measuring distance one-dimensional. What is the diameter of the coin? So this comes from your practice. So we can see right here, it's past 3. And we know this is 3.4. So I'm going to say 3.47, 3.48. Again, that 7 is an unknown. So 4.6, 4.8 are all acceptable because, again, that number at the end is an estimate. Here we have a card. Provide your best guess. Okay. We know it's 2, and we know this is 2.5, 2.6, 2.7, 2.8. So we know it's 2.8, and then we have to add a little something into that. I'm going to say 4, 5, 2. Sorry. All right, and then you can say, well, it's a square, so you know the length is 2.82 as well. So if you find area is length times width, and you get 7.95 centimeters squared. So why is it 5? Because when you do multiplication, you can only have so many digits as significant figures, and we will get to that soon. And that's just a little forewarning that that number would actually be rounded up to a 5. 3 dimensionals, a cube. So a cube here, cube is length times width times height, but they're all the same lengths and widths. So let's see, we got here 2.2 something, 2.25. Okay, so that means the cube would be 2 times 2.225 times 2.225 times 2.225, and you get 11.4 centimeters cubed. Okay, why is it cubed? Because you're taking centimeters times itself 3 times. Again, we'll talk about sig figs, but since you have 3 numbers here, you need your answer to be 3 numbers. Okay, volume of cube. So I get 1.567, 1.7. Okay, again, 1.70. So you need that little estimate at the end. So if it's on the line, you need that 0. Okay. And you take 1.7 times itself 3 times, and you get 4.91. So remember, you must calibrate instrument before you read it, so you know exactly how well you can make the measurements. Smaller calibrations mean more accurate measurements. Read an instrument out to the last digit is an estimate, so it's that little like at the end, like I don't know, it might be 2, I don't know, it might be 3. So you want to make that little estimate at the end, and then always include your units. All right, you're gonna do practice these on your notes. A, B, C, D, and E are on the more calibrated ruler. F and G are on the smaller, less calibrated ruler. Okay. All right. Any questions, let me know in class, and we will work on calibration of the ruler again on Blackboard and Teams.